All right, we are going to solve a system of equations by elimination. Okay, we're going to use the elimination method, and it is crucial to know that you need the opposite coefficients on one of the variables. In this particular problem, when I look at the x variable, I have two negatives and two different coefficients. I have -3 and -9. When I look at the y variables, I have a -3 and a +3. That is exactly what I mean by opposite coefficients. A positive and a negative, same number on that. So I can add these equations together and watch what happens. When I add these two equations together, I get -3x plus -9x, and I get -12x. And I take -3y plus +3y, and it's 0. It disappears. I'm not going to have y in the equation. Now I have 12 plus -24, and that equals -12. I can easily solve for x at this point, dividing by the exact value on that variable, and I get x equals 1. Now, when we solve a system of equations, we're looking for a coordinate where the two lines meet. So we know that the x is 1, and now that we've done that, we can simply put x in, or 1 in for x here, or here, whichever equation we think it looks easier. I think it looks about the same for both, so I'll just randomly pick the top equation and substitute 1 in for x right there. And now the equation only has a y in it, so I can solve for y. Two-step equation. And y equals -5. That point should work in both equations. I want to check that just to be super thorough. I just used this equation to determine my -5, but 1 and -5 should work in this equation as well. So I just want to check that. I'm going to put 1 in for x, 3 in for y. Excuse me, -5 in for y. And that'll equal -24. -9 minus 15. -9, -15. -9 minus 15 does equal -24.